Hello Internet. So I haven't done a lot of videos recently, but I want to get started again. And in this one, I want to show you how to use a tool called WORDij to do some basic text analysis. And if I say basic, it's actually, quite powerful stuff that isn't so hard to understand and is also not very difficult to actually do. So at the center of this video is going to be this tool, WORDij, which you can get from the internet. You can download it, and it is created by somebody called James Danowski. It's, I think, a very interesting tool, or rather a collection of tools, so you can do a whole bunch of stuff with that. And I'm actually only going to scratch the surface. I want to focus on two things that you can do with it, two things that I think go quite far in terms of analyzing textual content, whether that is, papers or some political speech, or even social media content taken from a platform like Twitter or Facebook. And the two things I want to focus on is, on the one side, what you could call a semantic network, and this is what you see here on the screen. And secondly, how to use WORDij to generate word frequencies and word pair frequencies. So what do I mean by that? Those are two lists that I have generated with WORDij from a paper that I'm going to use as the example throughout this whole video. It's a paper that you can find online. It's called Data Critique and Analytical Opportunities for Very Large Facebook Pages. And that's a paper that I've written with colleagues on data analysis for Facebook, kind of more technical stuff, but also around a particular case, which is the Kaluna Khaled Said Facebook page. And the reason why I'm using this is I want to suggest that it's very interesting for, not just me, but for everyone getting started with textual analysis to use something they know very well, right? And it's a paper I know very well. And if you work with something that you know very well, it really allows you to better understand what the tool does, to kind of see, okay, this is how it generates the output, and it helps, of course, with interpretation. So that's the basic example, and these are two frequency lists generated from this paper. The left one is a single word frequency, which isn't all that interesting. I mean, it's not uninteresting, but it's something that you don't need a tool like WORDij for. But here on the right already, you see word pairs, which is also sometimes called bigrams. And you can see that this is already much more verbose, right? So instead of just having data uses Facebook, we have social media, Facebook's API, research data, data analysis. Omitted for anonymity. This was from a draft version of that paper when it went through peer review. And these word statistics, and particularly bigram frequencies, are very interesting for comparison. Either comparison over time, for example, you take, let's say, a bunch of tweets and you divide them into, daily or weekly buckets, and then, analyze them with, analyze each of those buckets with WORDij. You then get, as an output, frequency lists like these ones here, and you can very easily then see how those lists change from time slice to time slice, or you compare different kind of documents that maybe represent particular political positions or kind of actor language for different groups, and this is something that those lists are really useful for. And that this kind of network view is not so good for. So this is a network representation of that same text that is based also on co-occurrence. So if words very often appear closely together in a text, they are related, and they can then be this graph can then be analyzed and visualized with graph analysis software. In this case, I used Gephi, and I want to show you how to do that. Here you get more like a snapshot view, kind of a structural snapshot view of the kind of the well, as Danowski calls it, the semantic network that kind of underpins that paper. But all of this is done in the WORDij software, which you can download freely from wordij.net. You simply have to fill out a questionnaire, and then you get a file. It works on Mac, Windows, and Linux, and I've already downloaded it here. You end up with this file, zip file. You unpack that, and then you drag it into your applications folder, and then so here on the left side we have the unpacked tool. Very important, there is a folder called documentation, and it's really good documentation. So there's a lot of info in there. So in this video, I'm just gonna work you through some of the basics to get started. But if you have further questions or want to dive deeper, this is the place to go. Very detailed, very good explanation. To start the program, you have here the .jar file, and on Mac you start that by simply opening it with the jar launcher, and then it starts WORDij. This is it. It has those kind of different panels that allow you to do different things. The most important one is clearly the word link part, which basically allows you to generate the output files for those different types of analyses that I have just shown you. There's also a tool for visualization already integrated, and a tool for comparing those word frequency files, which basically does some statistical analysis to show where are the commonalities, where are the differences. So when you run WordLink, you end up with output files that you can then use here as input. So I just want to walk you through the main features here, the main parameters, and give you an idea what happens, and the possibilities that are open to you. So to get started, well, we need an input file, and I've already prepared the same file I talked about before as an input. So it takes as input text files. You can convert a text file, a PDF file, or a Word file very easily to text, and then it's the input. The second element here is a drop list file, and this basically is a file that specifies which words you want to ignore. This very often concerns articles or kind of filler words, and WORDij already comes with such a drop list for English, which I've copied basically from the documentation here into the folder that I work with, and I can open that and add that here, and it will ignore all of the words defined in that list. So it's quite a bit here. You see, there's not just articles, but also stuff like across, about, and in your analysis, you will have to decide whether that flies, right? You basically use that filter to kind of filter out a lot of noise, but you may also lose some detail that you're interested in. So selecting a drop list is kind of an important step in that procedure. Next up is this checkbox here, which basically allows you to select whether you want to create a network file as an output, and that comes in PyEC format. PyEC is a very powerful network analysis toolkit. And this output format can also be read by other toolkits. For example, Gephi, which I've presented in several of my other videos. And so yeah, we want that checked. And then we basically have some thresholds for kind of filtering. If words appear not often enough, don't include them in the output file. Same for dot pairs. Of course, you can always filter that out afterwards. So I don't think this is very important. But what's very important is this part here, especially the window size. So how does WORDij establish whether two words are connected or not? The tool uses a method called a sliding window, right? So this here allows you to specify the window size to take into account. When you leave it to 3, and this is the recommended value, it basically looks at each word and then looks at the 3 words that come before that word and the 3 words after, and this is how they get connected, right? If you use here the method constant, all words in that window that then kind of slides over the text will be counted in the same way. So the distance between them is not taken into account. And if you choose linear and exponential, actually distance will play a role, right? So if you want to, take distance into account, I recommend looking in the documentation to better understand what happens here. In most cases, constant is just fine, and the window size of 3 is also just fine. So basically, if words are no further apart than kind of 3 words or 2 words in between, then they will be connected. The advanced options allow to do many more things. They allow you to specify a series of supplementary files that allow you, for example, to replace words with other ones. So, for example, if you want to, if in your case study you have some synonyms that you want to be reduced to a single word, you can specify that here. You can also specify basically the reverse of a drop list. So you can have this, include list file where you can say, hey, I want you to look only at these files, right? Maybe you have an expert vocabulary and you only want to, ignore, everything else. So that can be quite interesting. So lots of interesting possibilities. And then basically you have some other options here, some of them kind of technical, some exclusions, right? Some possibilities that, for example, allow you to define whether, the sequence in which words co-appear is to be taken into account or not, whether the sentence is basically a kind of a singular unit that the window doesn't ignore. So what do I mean by this? I told you there's this sliding window that slides over the text, and here you can basically decide whether it stops at a full stop, or whether it basically treats the whole text as a singular kind of chain of words. You can filter out HTML tags. You can remove punctuation. So there are a whole bunch of options. One that maybe requires a little bit more explanation is here the Porter stemming. This is basically a kind of a not all that complicated mechanism that tries to reduce, for English, different word forms to a single stem. I have prepared here a small example. So this is basically a kind of an online tool that shows you what a stemmer and this stemmer, the most famous one, Porter stemmer, does. And you can basically look, here's the input text, and here it shows how it intervenes. So for example, weakness is here being reduced to weak. So if you would take words like weaker, weakest, weakness, and so forth. That stemmer reduces them all to weak. So the idea is that basically stuff like plural or stuff like superlatives or different kind of word forms get fused into this singular thing. This sometimes creates, well, very often creates not very pretty output, right? So for example here, the E is cut off at the end, or tempted, temptation, tempted, tempting, all of that is reduced to this kind of singular stem. So that's not very beautiful, and you may then work through it again, but it really has the advantage of getting all of those kind of different word forms into a singular node or into a singular item here. So those are the advanced options. As always, I really recommend that you try out those different things, right? This is not something that this is some advanced kind of text treatment methods, and in order to better understand what their effects are, you have to try them out, and preferably with a text that you know well, again, right? And it's really important, because then you can really understand, okay, this is what's happening here. Oh, I understand this text, so I better understand how the processing affects what you get as an output. But this is basically it. We can now run this, and this is very, very fast. So WORDij is really, really well done. You can use hundreds of megabytes of text as input, and it's in that sense a really interesting tool to get an overview of large quantities of text. When you run it, it generates a log file, and that log file is also saved. And I really recommend keeping that, because it basically documents your methodological steps. So when you write a paper, you already have the different kind of decisions that you made, which have an effect on your findings, on your method. You have all of those steps here listed, and you can refer to that. So let's go into my file browser here, and you can see here on the right side it has generated a lot of new files. So this here was the original text. This is the zip file that stores WORDij, the drop list. So all of the others were actually generated by WORDij. I want to focus on 3 of them. Well, it's a log file just for documentation. But the 3 files I'm interested in is going to be that .NET file. That's the network file. And then these 2 CSV files that basically store frequencies for single words and for word pairs. Let's have a look at them real quick. I'm going to open them in Excel here, and you can see those are CSV files. You could also open that in OpenOffice or in Google Sheets. Excel does not automatically detect the formatting, but we can very easily add that. Simply mark that first column and go to data, text to columns, and delimited. Next, it's not a tab delimited file, it's a comma delimited file, and you can see, nice, it has detected that, and now you can see, okay, here we have those singular words and their frequency. There's also some statistical depth. Refer to the documentation to see what that does, and you can see here also the effects of the stemming, which I selected. So that word should be critique, but it has been reduced to critique, without an e. We could simply sort that and get the most common words in that text. The second file is the one with the word pairs. You can also have a look at that one. Same procedure, mark the first column, data, text to columns, delimited. Can remember that we selected the comma. And here we have the same thing now, but for word pairs. And we have here, Facebook API and so forth, all of those terms that play an important, those word pairs that play an important role in that paper. And like stuff like data access, data capture, data research, data analysis, data critique, those are all much more salient descriptors of the text content than those single words. So again, this is something you can use for comparison, and if you generate that for 2 sets of text, you can indeed use WORDij itself. Here let's close the log. The set utilities to compare 2 of these frequency files between time slices, between actor language groups and so forth. So this is word frequencies. The last thing I want to show you real quickly is how to create a network representation of that text. And I have already downloaded the Gephi graph toolkit, which is very easy to use. Some of my other videos I show how that works in more detail, so I don't want to go into the different options, but simply kind of quite quickly show you how this would go. I start Gephi. I open the .NET file, which Gephi natively understands. Open it here. It gives me some options. This is not a directed file, right? So there's no direction in those connections between words. They simply co-occur. So I'm going to set that to undirected. There's 486 words, 258 connections. So there's going to be some words that float around basically without connections. And that is set by those kind of thresholds that we could specify in WORDij's interface. I'm just going to open that. And of course, it doesn't look so nice. So what I'm going to do is I'm going to start with some formatting. Here you see all of those words that don't co-occur with anything kind of substantially. But in the middle, you basically get what you could call like the semantic core, maybe the semantic skeleton of that paper. I'll make that a bit larger, maybe 50. Yeah. And here you can already see the kind of structure emerge. And you can see there's also a thickness. So the more often 2 words co-occur, the thicker the connections. And of course, the Force Atlas algorithm, layout algorithm, is going to take that into account, going to prevent overlap. Things get more stable. And then you can, you use different metrics. For example, here the degree, which gives you the number of connections a node has. You can use that for size, maybe, maybe add some color. Could also, generate, the weighted degree from this. But I just want to quickly show you how that works. Okay, and here we get this network. So let's add some text to the nodes, make it a bit smaller. Yeah, and you can really see that you have basically 2 clusters. The top one here is more the technical side of that paper, which talks about Facebook's API, data, analysis, research, and so forth. It uses the term technicity a lot. And this is one of the focus points of that paper. And then here down there, you can see comment, post, user, numbers, count, time. So that's more the empirical part of that paper. And indeed, if you know that text, you can see that it really does provide a kind of an interesting distant reading type description of that content. So, one from here could go much deeper, but I really encourage you to try out WORDij. It's a pretty powerful tool, either for, kind of comparison or frequency extraction, particularly word pairs. I think very interesting, much better than single word frequency, or this kind of semantic network approach that allows you to get a quick overview of the contents of a textual corpus which could be like I used here, a paper, or it could be social media content. It's really something to try out and spend some time with to understand what's happening here. But it's definitely a tool I would recommend. Happy 2018. Bye bye.